So we're going to start off with the 45, 45, 90 triangle because it's the easiest of the two. Now, I'm going to discuss how this situation occurs, but you do not need to know why it occurs. You just need to know the rule. So,
Yeah, Ellie and Moshe aren't coming. They might be late because they're getting haircuts.
All right, that's a good thing I'm recording them. So I'll just post it on the YouTube, Google Classroom later. So let's pretend, and I'm purposely choosing across 45 to be A. This one has the same angle. So if they have the same angle in the same triangle, they're going to be the same size. So if this one's A, this one's also A. But what is this over here? Remember, we've done 5 days straight of Pythagorean theorem. A squared plus B squared equals C squared. Here's the thing though, this B squared is also an A. So I could write it as A squared plus A squared equals C squared. The only reason I could write that is because the angles are the same, which means the sides have to be the same. You only could do that with a 45, 45, 90. With that in mind, I could actually combine like terms because this is A squared and A squared. So I could do 2A squared equals C squared. Since I have one term each side, I can square root both sides. Now, the square root of 2, we don't know what that is. It's some decimal, so we're going to leave it as the square root of 2. The square root of A squared, that cancels out to just A. And the square root of C will just cancel out to C. Which means the square root of 2A equals C. What you care is the hypotenuse in a 45, 45, 90 is the square root of 2 times A. That's the only thing you actually care about. I'm just showing the proof for it, just to give a little bit of context. But what you care about is the hypotenuse in a exactly 45, 45, 90 is square root of 2 times A. Now let's go to the 30, 60, 90. The 30, 60, 90, I'm going to use the smallest one. So I'm going to say this one across here is A. And I'm going to tell you the hypotenuse in this case. Yes, they're two different questions. Good question. So we'll ask the question, are these two different situations? Yeah, they're two different situations where the angles have 30, 60, 90, or the angle has a 45, 45, 90 angles. And these are special, and then you'll see why they're special in a later set, but we need to learn what they are before we can use them in the full extent. So A is going to be across 30. I'm going to tell you 2 times A is going to be across of the hypotenuse. The hardest one to remember is across the 60 is going to be square root 3 times A. That's the hardest one. People forget that. But across the 60 is square root 3A. Across the 30 is A. And across the hypotenuse is 2A. Now, why does that happen? Let's pretend if I know 30 across 30 is A. So it's usually A squared plus B squared equals C squared. If I know this one's A, so I'll keep it A squared, plus I don't know what B squared is, but I know the hypotenuse is 2A. So I'm going to put 2A squared. And the whole thing squared, by the way, because 2 times 2A, whole thing squared. On the right, I could do the math here. So it's A squared plus B squared equals, distribute the square to everything, 4A squared. If I subtract the A squared on both sides, because we have two variables here, I'm going to get B squared equals 3A squared. Now I want to figure out what B is, which is across 60. So I'm going to square root both sides. B equals, I don't know what the square root of 3 is, so it's going to be 3. And I don't know what, but a squared is going to reduce to a. So that's why this side is square root 3a. And just like before, you don't need to know the proof or why it happens. You just need to know the rule. Across 30's a, across 60's root 3a, and across the hypotenuse is 2a. Notice that's different from a root 2a. That's for 45, 45, 90. Okay, so we're just going to do the 8 problems here, and then we'll call it a day. Anyone has any questions, though, about what I just set up? One and 2 have 45 degrees angles. So because it has 45-degree angles, we're going to use the 45, 45, 90. Now, how I do this problem is I'm going to label what my A's are. Since this one is a cross of a 45, this equals A. Because this one is 45 degrees, is across 45, this one's an A. And because this one is across, this one is root 2A. So we're going to find one piece at a time. So first off, I know A is 4. I get that freebie, which means I can substitute A with 4. So that means 4 equals X. Hey, that's another one I get for free. Because that's super easy, because X equals 4. They have to be the same size. In this one, I need to figure out what Y is. So I have to plug in A. We just figured out A is 4. So it's equal root 2 times 4. This is in a square root. Well, this is not in a square root. Because it's not in a square root, and this is a square root, we can't combine them. So we're just going to put them next to each other for root 2. So in this case, Y equals 4 root 2. You want to figure out what your A is, and then you're going to plug in for everything else. So you figure out A first. Let me type that out as instructions, because this is just like more of a worksheet than a normal notes page. Steps. Find the value of A. And then 2, plug in A for each side. Excellent. So that's correct. So let me talk it for everybody. Here, my A value, oh, I'm in pen mode for some reason. My A value, okay. My A value has to be 3 because it's across here. Since X equals A, which is across another 45 degrees, so this is also going to be 3. So 3 equals X. That's easy. Here, Y is the hypotenuse, which is root 2A. But I know A is 3, so I'm going to plug in 3 here. Root 2 times 3. They're not the same type of root, so 3 root 2 equals Y. So notice all I'm doing is identifying what A is, then solving. Now, why is that important? Because the first two seems pretty simple, straightforward. You just plug in the number, Mr. Tobel. Like you don't even have to do any math. This one is the different one. So this is 45, this is 45, this is the hypotenuse. So this will equal A, this will equal A. Well, this one equals root 2A. Okay. Actually, I should write it as A root 2. I'll write it as A root 2. So what's weird is A is not by itself in this situation. So what we need to do is solve for A. So what I'm going to do on the side is set up 2 root 2 equals A root 2. Now, A times root 2, I want to get rid of the root 2 here. So I'm going to divide root 2 so I can cancel it out. I have to do it to the other side. But what's perfect is that this cancels out also. So what we're left with is 2 equals A. Now, since 2 equals A, so we finished our first part, find the value of A. Since we did that, now we can plug it in for the formula. So A equals Y here. So in this case, we're going to do it as, since A equals 2, I could just plug that in. So 2 equals Y. And since A equals 2, I can plug that in. X equals 2. So straightforward, Y equals 2, X equals 2. Nice and easy in that one. Okay. Next one, same situation, U and V, but doesn't really matter. It's across 45, so this is A, and this is A root 2. Got to solve it out, so divide root 2 on both sides. Cross out, A equals 8, super easy, 8 equals U, and V equals 8. Okay, so first one, do straight plug in. Second one, do one step and then plug in. Let's go to the next set, 5 and 6 here. This whole thing equals A. Y equals A. This hypotenuse is going to be A root 2. Now, this whole thing equals A, 3 root 2, which means Y is also going to equal 3 root 2. That's easy. But here, remember, it's the A. It is the A that is equal to 3 root 2. So when I substitute it, it's 3 root 2 times this one over here, root 2. So it's A times root 2. I have to do it. Even if my A already has a root 2, I have to do it that way. Now, when you have two square roots, that they have the same power of the index, you could actually multiply the insides. So 2 times 2 is the square root of 4. But you guys are very smart. You know what the square root of 4 is. What times what gives you 4 happens to be 2. So 3 times 2. Then that results in 3 times 2. 3 times 2 gives you 6. So what happens here is that X equals 6. So that's why I say you have to find A, and then you have to find plug it in. That's why I've been doing it slowly. The first 4 seem straightforward. Example 6 will be the same situation as example 5, yeah. Next one for example 6, this is across 45, so this is A. This is across the other 45, so this is another A. And I don't like that it uses A, so I'll call it X. This one is the hypotenuse, so it would be A root 2. Now, I already know A is 2 root 2, which makes B 2 root 2. Now I need to find this, but I know A equals root 2 root 2, so I'm going to substitute that there. So it's going to be 2 root 2 times root 2. Inside roots can multiply to each other. So 2 root 4. The square root of 4 is 2. So 2 times 2. All overall is going to be 4, which means X equals 4. And I changed it to X because it was originally A, and and I don't want us to get confused. Good, Joel. Okay. Last one of the 45, 45, 90s, and then we'll be done for today. Okay. For this one, you have 45. This is 45. So x equals a and y equals a, while 4 is a root 2. So I need to figure out what a is, and this is the only one with a number. So I'm going to do a root 2 equals 4, divide root 2 on both sides. So I have a equals 4 over root 2. But remember, with our square roots, we need to rationalize it. We need to be able to multiply the top and the bottom so there's no square root. When you do this, yeah, no problem. When you do this, you're going to multiply the top and the bottom by the same square root. So right here, we have square root 2. So I'm going to multiply the top and the bottom by square root 2. What occurs if I get 4 root 2 over root 2 times root 2. But remember, if they're both in square roots, you can multiply it. So 4 root 2 over root 4. And you guys are very smart. You know what the square root of 4 is. 4 root 2 equals 2. And here's a trick so you don't have to do all the work. The number you have inside the square root is going to be the number that comes out of it if you do the same number top and bottom. So if I do root 2 over root 2, that's what's going to happen. Now, with that in mind, I have some normal numbers here, 4 and 2 to simplify. So I can rewrite that as 2 root 2 because 4 divided by 2 is 2 root 2. This is not in a square root, so it only affects this one because they're normal numbers. The square root numbers stay the same. So I did all of that to figure out what a was, which happens to be 2 root 2. If it was root 3, would it be root 3 over root 3? Yes. So a in this case is 2 root 2. So x equals 2 root 2 and y equals 2 root 2. Okay. They don't always cancel out. In this one, they did. Sometimes you have to leave it as a fraction. So like it could be like 11 root 2 over 2. That might happen. All right, everyone here, your exit ticket is to do number 8. You are free to go after you get it. I thought we're doing 2 root 2 times example, like example 6. No, we're doing it. This sample 7 and 8 is its own thing, which basically what's happening in this situation is that the hypotenuse is a whole number versus what you usually have, which is a root number, like we had in 4 and 5. So in this one, guys, you have to start off by setting this to a root 2. And I don't want square roots on the bottom, so figure out what you have to do after that. Everyone should be trying this out. This will be your exit ticket. I'm just putting that line there so it's easy to me to see where the exit ticket starts when I check the attendance for later. So everyone should be trying that out. I'll be doing it slowly, silently over here if you need to look up and check your work along the way. Morty, you're free to go. Good job, man.
Thank you.
No problem. Zohar, this number is 7, but you have to set it to equal a root 2. So if you can see in this step, I have to divide root 2 on both sides. So right now, I have 7 over root 2. Ask yourself, what do you need to do so the root doesn't have to be on the bottom? And if you're
Got it.
unsure, look at the problem previously.
Got you. Got you.
Okay. Shaul, you are correct. You're free to go if you wish.
All right, thank you, Mr. Stovall. Have a good day.
No problem, man. You too. Zohar, so you set them equal to each other, but that's not what you want to do. You need to multiply by a specific fraction. You need to multiply by a very specific fraction to get rid of that root 2. Oh, does anyone have Kobe's number? Can you text him to actually show up to class? Because if he doesn't show up, he's not going to be able to make up his test. And if he doesn't make up his test, he's going to get a bad grade. There should be something underneath that somewhere. 7 root 2 over what?